In this video, we will introduce solderless breadboard, also known as a prototyping board, how it is configured, and how it is used. Each small hole on a breadboard is a connection point. Inside of each connection point is a small spring clip, also known as a socket, that will hold a wire in place while allowing a secure electrical connection to exist. The plastic housing material of the breadboard is non-conductive and not resistant to heat, so never try to solder on the breadboard. The small sockets that are housed down the hole are electrically conductive. The connection points on a breadboard are connected in lines called strips. There are bus strips and terminal strips. The bus strips are color-coded with red for positive and blue for negative. The terminal strips are labeled with numbers to indicate the horizontal rows and letters to indicate the vertical columns. These connection points are connected horizontally with A, B, C, D, and E connected and F, G, H, I, J connected. If we remove the non-conductive plastic material that houses the spring clip, we can see the positive and negative bus strip run the entire length of the plastic but are not connected to one another. The gap between the E and F on the terminal strip is called the center line and indicates they are not connected. This gap is useful for building circuits. A component or chip can bridge this gap without a short circuit. Again, if we remove the non-conductive plastic material that houses the spring clip, we can see row 1 and row 2 are not connected, but A, B, C, D, and E are connected on one piece of copper. F, G, H, I, J are also connected together. Using the breadboard to build circuits is easy. First, the wires inserted into the breadboard, called jump wires, should not have too much wire exposed and not too little. If there is too much wire exposed, the wire could touch other components and create a short circuit. If there is too little wire exposed, the rubber insulation could get caught in the spring clip and prevent a good connection. It is also important not to force a wire or component lead that is too large into the opening, as this will damage the housing and potentially crush the spring clip. It's very easy to connect the bus strips together so there is electrical conductivity. Simply use jumper wires to connect the power buses together. This can also be done with the ground buses. If needed, the terminal strips of the breadboard can be connected to make a longer component bus. To plug a power supply into your breadboard, first connect the post to the appropriate bus line. Simply unscrew the sheath on the binding post, insert a wire into the hole in the post, then plug that wire into whatever connection point is needed. It's a good idea to connect a positive binding post to the red positive line of a bus line and the ground binding post to the blue negative bus line. Connecting your breadboard to a power supply is as simple as plugging a banana plug into the socket on the top or clipping an alligator clip onto it. When a circuit is being built or changed, the power should be turned off. No connection should be made when power is applied to the breadboard. A simple series circuit can be built on the breadboard by connecting a power supply to the binding post. Then use a jumper wire to bring the power down to the bus strip. The positive bus strip now is electrically connected to the positive power supply input. The same can be done for the negative. Now the resistors can be inserted into the terminal bus strips. Most components have 2 or more leads. These leads should never be inserted into the same terminal strip. That would essentially be a short. The resistors will be electrically connected from the positive bus strip to the negative bus strip. Notice that the actual configuration of the electrically wired components does not look exactly like the schematic. More complex circuits can be built on breadboards, and they're a great tool when building experimental circuits. Just remember how the different strips are electrically connected to each other, and remember good practices to follow for safety and making good electrical connections with components and jumper wires.